Hello, hi everyone. Welcome to the Student the Brand. Today we are going to discuss about vectors topic. Vectors, vectors, CBSE, grade 11, physics. So in previous live class, we discussed about vectors. In the previous live class, we discussed about vectors types. Okay, so vectors, what is vectors? What is physical quantity? So quantity is nothing but it gives the answer for how much or how many. It gives the answer for how much or how many. Okay, so we'll discuss once again all the points. Once again, we will discuss. So quantity is nothing but quantity. Quantity is nothing but so when you are going to the shop and if you ask, I want rice. So will they give? So immediately they will ask two questions. Immediately they will ask two questions for how much or how many. It gives the answer for how much or how many. That is our amount, vastness also we can say. That is called quantity. So next one, physical quantity. Physical quantity is nothing but the quantity which can be measurable. The quantity which can be measurable is called physical quantity. The quantity example mass we can take mass and speed, like that so many so many we can take, etc. So we can take many. So few are taking quantity, physical quantity. Next one, so types of vectors we discussed. Types of vectors like equal vector, negative vector, co-initial vector, co-terminal vector, null vector. Okay, so localized vector, non-localized vector, coplanar vector, like that many. So many we discussed. Now in this topic, yes. So in this topic, especially we'll discuss about resolving. Okay, resolution of a vector into rectangle components. Resolution of a vector into rectangular components. Resolution of a vector into rectangular components. Rectangular components. Okay, so how we are discussing, how we are converting or resolving it to rectangular components, we will discuss. Right now you can see here I'm taking three axes, x axis, y axis and z axis. So listen carefully. X axis, y axis and z axis. So z axis, x axis, y axis and z axis. I am taking one vector, that is, so I am considering a bar. I am taking a bar. Suppose I am taking a bar. Okay, along x-axis, the unit vector is I cap. Along y-axis, the unit vector is j cap. Along z-axis, the unit vector is k cap. So as we already know about it, unit vector is nothing but unit vector. If I am taking a bar is nothing but, okay, so xi cap. So along with X-axis I'm taking, that's the unit vector. Unit vector I'm representing. Suppose unit vector can be represented, unit vector A cap equal to A bar by mod A bar, right? So vector itself by mod of the vector, right? So we have to take magnitude. We have to consider magnitude of the particular vector. Suppose I am taking A bar. So A bar along with x-axis we are taking the component. So we can also take, so if you are taking along with this component I am considering, along with this set component we are considering. Okay, so if you're resolving the components, first we will discuss with only two axes, then we'll go with the third one. Only with two axes we'll discuss, then we'll go with the third one. So a bar will make theta with the x-axis I'm taking. Okay, so along with that, so x-axis if I'm considering. So a bar is resolving the component until the component of a bar component is I'm taking ax, or if you're taking that component, only this component, if you're considering x also we can take particular component, we can consider x also. Right, so along with the x-axis I am taking ax, along with the y-axis I am taking a y. Suppose if you are taking the same right angle triangle, if I consider, okay, so this component I am considering x. So if you are taking like this, okay, so this the so only magnitude I am taking, this is theta, and this is the x-axis and y-axis, right? Now cos theta, what is the cos theta formula? Cos theta equal to adjacent side by, cos theta equal to adjacent side by hypotenuse. So x by a, that is x equal to a cos theta, x equal to a cos theta, and sin theta formula is sin theta equal to, what is the sin theta formula? Opposite side by hypotenuse, opposite side is y, hypotenuse is a, so y equal to a sin theta, a sin theta. So x equal to a cos theta. A cos is the component of a bar along x-axis. A cos theta is the component of a bar along x-axis. So a sin theta is a component of a bar along y-axis. Along y-axis. So that's why I'm taking here. So this is the y-axis. This is the x-axis I'm taking. So y equal to, because it's a parallel to this one. So this component, until this component I'm taking, that is a sin theta, and this one, if this component only until here, if you are taking x equal to a cos theta, x equal to a cos theta. So this also we can write ay also we are taking. So vector a along, vector a component along y-axis. So vector a component along y-axis, a bar vector component along y-axis, ay equal to y equal to a sin theta. So vector a bar along x-axis ax, that is also equal to a, x equal to a cos theta. So like that also we can consider. Now, so we can write a bar equal to a bar equal to a bar. So a bar we can take xi cap plus yj cap. As we know that x equal to a cos theta, a bar equal to a cos theta I cap plus a sin theta j cap, right? So as I know, so just before I said I cap, j cap, k cap, I cap, j cap, k cap are the unit vectors. I cap, j cap, k cap are the unit vectors. I cap is a unit vector along x-axis. J cap is a unit vector along y-axis. K cap is a unit vector along the z-axis. Once again, I cap is a unit vector along x-axis. J cap is a unit vector along y-axis. K cap is a unit vector along z-axis. So z-axis we can consider, right? Now, so if you are considering here, so a bar, if you are taking magnitude of a, if you take root over a cos theta whole square plus a sin theta whole square I am taking, right? So I am considering now. So here if you are taking magnitude of a bar, that is magnitude of a bar. So a square, so root over a square cos square theta plus a square sin square theta. So here we can take a square common. Shall we take a square common? So if I'm taking a square common, magnitude of a bar equal to, so root over, so a square I'm taking common, cos square theta plus sin square theta. Cos square theta plus sin square theta. So what is sin square theta plus cos square theta? Sin square theta plus cos square theta. Okay. So sin square theta plus cos square theta equal to 1. So very important. Sin square theta plus cos square theta equal to 1. Sin square theta plus cos square theta equal to 1. Right? So here I am taking mod a bar equal to root over a square. So 1 I am taking. So square get cancelled. Mod a bar can be also write simple a. Okay, like this also we can take. Like this we can consider. Understood? I hope it is very clear. I hope it is very clear. Once again observe carefully. So resolution of a vector into rectangular components means perpendicular. Okay, I hope it is very clear to you all. Now you can observe. So along x-axis I cap is the unit vector, along y-axis j cap is the unit vector. So x-axis x equal to a cos theta, y equal to a sin theta. So if you are resolving the component, so resolving the component into so resolving the component along x-axis and y-axis. So a bar equal to xi cap plus yj cap. So now you can take, so from right angle triangle, so just now we did, that is right angle triangle if you are considering here theta. So component I am taking here x and y. So cos theta equal to x by a, x equal to a cos theta. Okay, so sin theta if you are taking sin theta equal to y by a, y equal to a sin theta. Right? So I hope it is very clear to you all. Now you can observe. Understood? So a bar equal to a cos theta I cap plus a sin theta j cap. Mod a bar equal to root over. So we are taking only magnitudes. So we have to consider magnitude a cos theta whole square plus a sin theta whole square. So a square cos square theta plus a square sin square theta. So mod a bar equal to root over a square cos square theta plus a square sin. So sin square theta. So root get cancelled. So this is the remaining. Okay, so that's enough. Now, even so here until here we took two axes. If you are taking z axis, if you are considering z axis, So A bar I am considering here, A bar I am taking this A bar, this is x-axis, x-axis, y-axis and z-axis. Okay, z-axis I am taking. Along x-axis I cap I am considering. Along x-axis I cap. Along y-axis j cap. Along z-axis k cap I am considering here. So A bar makes with x-axis alpha angle, alpha. So A bar with B, so with beta, and A bar with z-axis gamma I am considering, gamma. Once again. So with x-axis, so x-axis, y-axis, z-axis. Along x-axis I cap, along y-axis j cap, along z-axis k cap. Right? Once again, along x-axis I cap, along y-axis j cap, along z-axis k cap. So A bar makes with x-axis alpha angle. A bar. So A bar. So A bar makes with y-axis beta angle. A bar with z-axis gamma angle. Now I am considering here. Okay. So A bar equal to xi cap, yj cap, zk cap. Xi cap. So xi cap, yj cap, zk cap with the components. So if you are taking, so suppose I am taking this is the alpha. So I am taking one triangle I am taking with example. So this is alpha I am taking, x-axis component is A. So we need only cos alpha. So cos alpha equal to, so I'm taking only cos alpha. So remaining angles will be the same. So that's why I'm taking just cos alpha. If you take cos alpha, so if you take the cos alpha, x by a I'm taking. So x equal to a cos alpha. So whereas y if you are taking same, so if your triangle y if you are considering y equal to, so beta, so with x-axis alpha, with y-axis beta, with z-axis gamma. Understood or not? Once again, with x-axis alpha, with y-axis beta, with z-axis gamma. So same remaining a cos beta. So z-axis equal to a cos gamma. Right? Now you can take, so cos alpha equal to x by a, cos beta equal to y by a, so cos gamma equal to, because we are taking only one vector along x-axis, y-axis, z-axis, that is a bar, right? A bar I am taking. That is the reason. Now if you substitute here, so a bar equal to a cos alpha I cap plus a cos beta j cap plus a cos gamma k cap. Right? So everything again, if you are taking the mod, so everything again will get a cap. So cos alpha plus cos beta plus cos gamma equal to 1. So directional cosines we are taking, directional cosines we are considering. That's why 1 we are considering. Right? Okay. So that's enough. That is about even from this also, sir, how you are getting that one? So just look into that one. Okay, how you'll get that one? So just check once here. So I'm taking a bar equal to, root over, so magnitude I'm taking, magnitude if you are considering x square plus y square z square. So if you are taking a square equal to x square plus y square plus z square. So you can take this one. So a square equal to x square plus y square plus z square. Even if you take from this also, so from here also you can observe, from this one I am taking here. Okay, now from this one you can take cos alpha equal to, from here cos alpha equal to x by a. From here cos beta equal to x by b. Okay, sorry, x by a only, x by a x by a. From this also cos gamma equal to x by, sorry, y by a. This is y, right? Y by a. Here z by a. Yes or no? Z by a. Right? Once again listen carefully here. Once again listen carefully. X equal to a cos alpha, y equal to a cos beta, z equal to a cos gamma. So now you want to find out x by a equal to cos alpha. Cos alpha equal to x by a. Cos beta equal to y by a. So a will, so yeah, simply we can take a this side. That's enough. Then we'll get cos alpha equal to x by a, cos beta equal to y by a, cos gamma equal to z by a. That's enough. Is it clear? So I hope it is very clear to you all. Just check once. Now if you are taking cos square alpha plus cos square beta plus cos square gamma equal to cos square gamma equal to here x by a whole square plus y by a whole square plus z by a whole square. Okay, so x by a whole square. So if you observe carefully, you will get it. Check once. X by a whole square plus y by a whole square plus z by a whole square. Right? Now we'll get from this one x square by a square plus y square by b square, y square by a square, y square by a square plus z square by a square. So we can take common now cos square alpha plus cos square beta plus cos square gamma equal to, here we can take x square plus a square is common. A square is common. We can take a square common. A square we can take common. X square plus y square plus z square by a square. So here as you know, x square plus y square plus z square equal to a square. So a square by a square, you can cancel it, then 1. So that's why cos square alpha plus cos square beta plus cos square gamma equal to 1. Yes or no? Cos square alpha plus cos square beta plus cos square gamma equal to 1. Okay. So now once again you can observe. Here x-axis, y-axis, z-axis, along x-axis I cap, along y-axis j cap, along z-axis k cap. So a bar makes at x-axis alpha, a bar makes with y-axis beta, a bar makes with z-axis gamma. So a bar we are writing with the help of x-axis, y-axis, z-axis. X-axis, okay, x-axis, y-axis, z-axis, that is a bar equal to xi cap plus yj cap plus zk cap. A bar equal to a cos alpha I cap plus a cos beta j cap, a cos gamma k cap. So mod a bar if you are taking root over, so from here I am considering, from here I am taking, from this one if you are taking, okay, like this. So a square equal to x square plus y square plus z square. So from this triangle, so from this xy, x-axis, y-axis, z-axis, we can write like this. So by taking this formula from this one, okay, so we can write x equal to a cos alpha, y equal to a cos beta, z equal to a cos gamma. Cos alpha equal to x by a, cos beta equal to y by a, cos gamma equal to z by a. So we can take cos square alpha plus cos square beta plus cos square gamma equal to x by a whole square plus y by a whole square plus z by a whole square. Then if you are taking squaring on both sides, Okay. So now cos square alpha plus cos square beta plus cos square gamma equal to x square plus y square plus. So from this one we can take a square equal to x square plus y square plus z square. A square y square get cancelled. So the remaining value is 1. Okay. So now we can take cos square alpha plus cos square alpha plus cos square beta plus cos square gamma equal to 1. Very, very important. Very, very important. So cosine, directional cosines, directional cosines, and one more thing also there. So sine square alpha plus sine square beta plus sine square gamma equal to how much? So that answer is, so we will get, I will try, I'll solve it. So just check once. Okay. So now you can see here. So we know sine square theta plus cos square theta equal to 1. Sine square theta plus cos square theta equal to 1. Yes or no? Now cos square theta plus cos square alpha. Cos square alpha. Cos square alpha plus cos square beta plus cos square gamma equal to 1. We know from this. So from this we can take. Suppose in case sine square alpha plus cos square alpha equal to 1, cos square alpha equal to 1 minus sine square alpha. So in that way if you write, in this way if you write, now you can see here 1 minus sine square alpha plus 1 minus sine square beta sine square beta plus 1 minus sine square gamma. Gamma equal to how much? So we need to, so we have to find out sine square alpha plus sine square beta plus sine square gamma equal to how much? So that is a question. So we need to find out. We need to find out once again sine square alpha plus sine square beta plus sine square gamma equal to how much? That is the question. That is the question. Now you can see cos square alpha plus cos square beta plus cos square gamma equal to 1. We know that. So we know sin square theta plus cos square theta equal to 1. So standard format. So we know sin square alpha plus cos square alpha equal to 1. So cos square alpha equal to 1 minus sin square alpha. So now we can take 1, 1, 1. So total 3. 3 minus 3 minus sin square alpha plus, so this one we already we know, right? This one. So sin square beta Sine square beta plus sine square gamma equal to, so anyway this one cos square alpha plus cos square beta plus cos square gamma equal to 1. So I'm taking this side. Now 1 minus sine square alpha, 1 minus sine square beta plus 1 minus sine square gamma equal to 1 anyway. So 1 this side. Now, so better you take this side and 1 this side, then sine square alpha sine square alpha sine square alpha plus sine square beta plus sine square gamma equal to sine square gamma equal to 3 minus 1, that is 3 minus 1. Now we'll get it. Sine square alpha plus sine square beta plus sine square gamma equal to 2. So this is the answer. Answer is 2. Check once. I hope it is clear to you all. Answer is 2. Do you have any doubts in this? Answer is 2. Okay. So then I hope it is very clear to you all. So once again check. Plus cos square beta plus cos square gamma equal to 1. We know that. Sin square theta plus cos square theta equal to 1. We know that standard one. So sin square alpha plus cos square alpha equal to 1. So cos square alpha equal to 1 minus sin square alpha. In the place of cos square alpha, I am substituting 1 minus sin square alpha. Cos square beta 1 minus sin square beta. So cos square gamma 1 minus sin square gamma. So here anyway this value total is 1. I am substituting here. So 1 minus, so we can 1 total 3 minus sin square alpha plus sin square beta plus sin square gamma, you can take it out. Okay, then I hope it is very clear. 3 minus 1 totals we want sin square alpha plus sin square beta plus sin square gamma, you take that side, then 3 minus 1 is 2. So that is the answer, right? I hope it is very clear. Next one. So done. Next one. Product of vectors. So there are two types of product of vectors. One is dot product, another one is cross product. So product of vectors, there are two types of vectors. One is dot product, it is also known as scalar product. Cross product is also known as vector product. Now we will discuss about dot product. Now we will discuss about dot product. Okay. Dot product of two vectors is equal to, okay, so dot product of two vectors is equal to product of their magnitude and cosine angle between them. A bar dot B bar, if you are taking dot product equal to, so A bar dot B bar, A bar dot B bar equal to AB cos theta. AB cos theta. Dot product of two vectors is equal to product of their magnitude and cosine angle between them. Once again, dot product of two vectors is equal to product of their magnitude and cosine angle between them. That is A dot bar B bar equal A bar dot B bar equal to AB cos theta. Okay. Now, so dot product process commutative, follow commutative law. A bar dot B bar equal to B bar dot A bar. So it follows distributive law. A bar dot B bar plus C bar equal to, so A bar dot B bar plus A bar dot C bar. Okay. So if you are considering here, second one, third one, if you are taking A bar dot B bar is equal to A into B cos theta. So B cos theta is the component of B bar vector along A cap, along vector A, along a vector A bar. A bar dot B bar, if you are taking B into A cos theta. A cos theta is the component of A bar along the vector of B bar, right? Yes. So A bar dot B bar in the orthogonal vectors, if you are taking, so A bar dot B bar along the x-axis, y-axis, z-axis we will discuss. So I cap dot I cap equal to I cap J cap dot J cap equal to I cap dot I cap equal to J cap dot J cap equal to K cap dot K cap equal to 1, right? So I cap dot J cap dot K cap dot I cap equal to 0, because these are the perpendicular vectors. If you are taking here along x-axis, y-axis and z-axis, I cap, J cap and K cap. So along the same direction, cos 0 is 1, cos 0 is 1. Okay, so cos 0, if I'm taking, cos 0 value is 1, cos 0 is 1, cos 90 is 0, right? So that one, I cap dot I cap cos 0, 1. That's why one value are taking here 0, because those are perpendicular vectors. So that's why we are considering. So along I cap dot J cap cos theta, Ij cos theta, cos 90 degrees, cos 90 is 0. That's why here it is 0, here it is 1. Yes or no? So next one, we'll see one more. So along the Cartesian coordinates, if you are taking, so orthogonal vectors we discussed now. So Cartesian coordinates and along the x-axis, y-axis, z-axis, if you are considering. Now A bar if you are taking, A bar if you are considering AX, or we can take AXI cap plus AYJ cap